The nature of soldered connections poses a permanent challenge for electronics production. Today we provide analysis and solutions at the same time. Today we use a new technological approach to produce trouble-free and high-quality soldered joints. We refrain from popular approaches and focus on the thermodynamics within the solder during thermal processes. I am Landolf Skoda. I'm working as a PCB assembly operator, and I am introducing this new convergence pad. On a specially manufactured PCB, we compare the results of the common process with those of soldering with the convergence pad and heat lifting. Using a variety of solder alloys, we have designed the connections for this with an identical thermal load. The shrinkage of the solder in the direction of heat dissipation and the partially convergent cooling of the left hand can be observed. The comparatively abrupt cooling of the remaining area shows that a definite direction of heat dissipation is no longer present here. The high heat saturation of the pin also becomes apparent. The resulting disordered cooling produces the granular and rough texture within the solder. The flux inclusion, already visible in advance, persists in the problem zone due to the disorderly cooling. A flushing out due to convergent compression of the solder can therefore not take place. Heat oversaturation exacerbates the disorderly cooling process. The persistence of the solder is equally opposed to the shrinking forces. The soldering temperature itself must be discerned from the degree of heat saturation. Even with an increased amount of solder, defects in quality cannot be avoided. The shrinkage of the solder in the direction of heat removal is again clearly visible, as well as the abrupt cooling of the remaining area. Problems regarding thermodynamics also occur with lead-based solders. The shrinkage of the solder in the direction of heat dissipation is characterized as a reversal effect, the so-called solder flow direction, which takes place when heated due to the higher expansion of the solder. The well-known phenomenon of the solder flow direction can be used to explain the various types of disturbances as a result of divergences in the solder. With the new convergence pad, however, we can shape the solder. Based on the new convergence pad, we demonstrate heat lifting as a first category of the new technological approach. Operative divergency clearance. Inconsistent expansions of the solder must be corrected operationally during the heat process. We go beyond the state of the art and assign the cooling of the solder a clear course. In addition to the soldering iron illustrated here, the convergence pad is suitable for any process type with a directed heat source, such as radiation soldering processes. The soldering tip, as the permanently warmest area, is guided out of the soldering point in a regulated manner. The cooling of the solder is therefore convergent in the direction of the heat source. Another flux is not used in addition to the flux contained in the solder tube. Even if the soldering temperature is set too high, the distance from the solder joint can be further increased by the adhesive force of the solder so that the convergence effect can occur. In order to reduce the calculation of the parameters to a minimum, this type of procedure is recommended as obligatory for automated processes such as robot soldering. With a view to the operational requirements and the economic efficiency of hand soldering, even simple rework with reduced soldering temperature leads to the desired success. The working principle shown here also opens up new approaches to process engineering for reflow and wave soldering processes. With the new convergence pad, however, we can shape the solder. Based on the new convergence pad, we demonstrate heat lifting as a first category of the new technological approach, operative divergency clearance. Inconsistent expansions of the solder must be corrected operationally during the heat process. We go beyond the state of the art and assign the cooling of the solder a clear course. The convergence pad is also suitable to effectively perform rework operations after flow or reflow assembly. The introduction of the heat source via the expansion of the pad significantly favors the melting of the solder. The particularly high thermal conductivity of copper can thus be brought to bear. A fault line, discernible as a dividing line, is caused by opposing heat dissipation between the component and adjacent conductor paths. With a minimal demand on the available space, the convergence pad also facilitates a gentle processing of the contact and the component by considerably reducing the risk of thermal shock. The advantages of the convergence pad are evident, not only by the operational flexibility, the gentle handling, and the reproducibility of excellent results. It also serves as a visible trademark for a novel and unquestionable quality. Sporadically, or also due to incomplete melting of solder joints during rework operations, results seem quite acceptable after common handling. However, an adequately executed heat lifting also shows a different finish inside a connection. Ultimately, we therefore give primacy to one principle over existing standards. Don't let the solder off the line.